Hi everyone, welcome to ESE Engineering Academy and ESE Online. This is Pabba Ramesh, faculty at ESE Engineering Academy. Now in this session, I am going to discuss important concept in the measurement subject. Here we are going to discuss important concept in the measurement subject. So already in the last session, just 2 days back, we have taken one session on preparation strategy. Yes or no? But in this session, we are going to discuss about important concepts of measurement subject. But in this 1 hour of session, we cannot cover entire syllabus. That's why I have taken a particular topic where more weightage, right? And then concepts are also very important in the ESE as well as GATE 2024 exam, nothing but ESE and GATE examinations I can say. I am going to take one important topic in this session that is having little bit more weightage and then concepts are also very important in these examinations. Okay, with this introduction, now I am starting the session, that is important concepts in the measurement subject, that is measurement of power. In this today's session, we are going to discuss about measurement of power. It is very important conceptually, right? What is it? Power measurement. In what way we can measure the power, right? What are the methods available for measurement of power? Complete introduction will give you. And from this entire biggest chapter, biggest topic I can say, I am going to take a special topic called reactive power measurement. Reactive power measurement concept. After that, reactive power measurement related question, and after that, in this entire measurement of power, all corresponding different numericals we are going to take. From this today's session, right, numerical questions are taken into consideration, 2 marks questions in the GATE. In the conceptual model, either in the ESE and in the GATE paper, 1 mark question in the GATE paper, ESE prelims paper questions are generally possible. Okay, now let us start the topic, that is measurement of power. Now I am going to give you introduction regarding the measurement of power. So what is this? What is this? Complete introduction will give you, but after this a special topic called reactive power measurement. Let us see. Sir, power can be, measurement of power can be categorized into 2 cases or 2 types, DC power measurement and AC power measurement. One is DC power measurement, one is AC power measurement. In the DC power, what is the general formula? P is equal to V into I. P average is equal to V into I. Therefore, P average equal to V into I. Okay. Now, sir, this power can be measured by which device? EMMC device, that is electrodynamometer device or electrodynamometer wattmeter. In the same way, AC power also can be measured by AC meter, AC wattmeter, electrodynamometer, AC wattmeter we can. Now, other than this, one more method is also there. Other than this, one more method is also there. So what is that method? By using PMMC. By using PMMC, but not PMMC wattmeter. It is PMMC voltmeter and ammeter. PMMC voltmeter and PMMC ammeter. Sir, PMMC voltmeter reads which value? V average. PMMC ammeter reads I average. So therefore, V average into I average, that is DC power. In this way, we can measure the corresponding DC power. Now coming to single phase AC power. Coming to single phase AC power. Sir, in this single phase AC power, first of all, what is the formula? Power single phase is equal to, everyone knows that, V phase, I phase, cos phi. V phase, I phase into cos phi. Now, which method is used to measure the corresponding power? That is EMMC, electrodynamometer wattmeter also we can say. EMMC instrument, electrodynamometer wattmeter, right? Now, those who are on the line kindly respond. Am I audible? Right? No. Sir, after that, 3-phase power measurement. Power 3-phase. Power 3-phase is equal to root 3 VL IL into cos phi, root 3 VL IL into cos phi. And for this also we can use EMMC instrument, nothing but with EMMC instrument we can measure the corresponding power. Okay, this is a simple introduction. I am moving aside for few seconds. You can see the entire thing, that is DC power measurement and AC power measurement. DC power measurement by EMMC as well as PMMC voltmeter ammeter, single phase power by EMMC and three phase power by EMMC. Now, sir, in this three phase power measurement, how many, in this three phase power measurement, how many methods are there? 1 watt meter method, 3 watt meter method, and then universal method is 2 watt meter method. So this is the complete introduction regarding the power measurement. Okay, now out of all different methods, in this session I am going to take a special topic, special connection based method, that is measurement of reactive power. This is reactive power measurement by 1 watt meter. We are using only 1 watt meter, but we are going to get reactive power. Generally, those who are preparing for the GATE and ESE, right, those who have completed this chapter in your preparation, you know that 2 watt meter method is there to get the reactive power also, right? 2 watt meter readings W1, W2 are there. W1 minus W2 gives the reactive power, that is the general known to everyone, but it is a special topic where we can get reactive power, by 1 watt meter. But this is a specific connection, I can say special connection, so that's why I am giving that. Sir, in this, right, in order to get the reactive power with 1 watt meter, how we have to connect the watt meter? How we have to connect the watt meter in the circuit? You know, current coil is in one phase. Current coil is in one phase. Current coil must be connected in one phase. Okay, and potential coil is between other two phases. Potential coil is between other two phases. So in this special connection, we can measure the reactive power. In what we are connecting? Current coil is in one phase. Assume that current coil is connected in R phase. Okay. Potential coil is between other phases. Potential coil is between other two phases. What does it mean? If the potential coil is connected between other two phases, what does it mean? Simply Y and B methods we can say. Okay. One is R phase and other is Y and B phases. If this is the case happen, automatically we can say yes, reactive power we are going to get. Reactive power we are going to get. How, sir? Let us see. I am going to take a star connection just for explanation purpose. One of the connections I am taking. This is star connection. Right? This is R, this is Y, and this is B, R, Y, B. And this point is called as neutral. Okay. Just for analysis purpose, we are taking, no, I am taking balanced load Z, Z, Z. If all the load impedance are equal, we can say balanced load. 120 degrees phase shift will be there, that I will show in the phasor diagram. That is balanced load. I am taking balanced load like this. Okay. Now I am connecting current coil in one phase. Current coil is in one phase. Where I have connected the current coil? In R phase I have connected. After that, potential coil is between other two phases. Potential coil is between other two phases. One is like this. Potential coil is between other two phases. Okay. Now in this connection. Whatever the wattmeter reading is there, that is giving the reactive power. That is what our entire analysis. That's why here I would like to say now, generally this I'll say in my class every time in this chapter. Whatever may be the wattmeter connections given in the examination circuit, don't worry first. By looking at that entire figure, don't get afraid of that figure first, right? First observe the wattmeter connections, where the current coil connection, where the potential coil connection, enough. If you observe that properly, answer is very, very simple. How may be the, or whatever may be the different connections given, no need to worry. Observe the connections and proceed the steps what I am going to say. Okay, what is it? So in this wattmeter reading we require, right? No. Generally we know that wattmeter reading, W is equal to, generally how the reading of wattmeter comes into picture means voltage across potential coil, current through current coil, and cosine of phase angle between those two. So simply voltage across potential coil, current through current coil, cos of angle between voltage across potential coil and current through current coil. Voltage across potential coil and current through current coil, like this. Okay. Now by looking at the circuit connection, write it. Sir, where we have connected potential coil, according to that only voltage will be there. No, the potential coil is connected across, potential coil is connected across which value? Y and B. So simply VYB I am writing, VYB. But people are asking the doubt, sir, why not BY? You can write that also, but generally I am following RYB sequence. If nothing is given, generally it is advised to follow RYB sequence. It is advised to follow RYB sequence. Okay. Now, current coil current. Now check it. Through the current coil, which current is flowing? IR. R to N means IR. So current coil current is IR. And cosine of, yes, cosine of angle between VYB and IR we require. That's it. If you are able to observe the circuit connection, if you are able to write these equation or this equation, yes, half of the problem is done. Half of the tension will be removed. That is what the point. So that's why kindly focus on this. What is the corresponding thing? Now, let us have the phasor diagram. Let's have the phasor diagram. Which sequence we are following? RYB sequence we are following. So therefore, simply RYB sequence we are following, right? Now I am taking, this is VRN. This is VRN. Okay. And this is VYN. This is VBN. VRN, VYN and VBN. Sir, 120, 120, 120 degrees. It is a balanced system. Okay. Sir, in this question, nature of the load is not given. No, just assume that lagging load. You can take leading load also, no issue. I am assuming like it is a lagging load. Okay. Right, sir. If it is a lagging load, IR lags the VRN. So therefore, this is IR lags the VRN by phi. IR lags the VRN by some degrees, 20, 30, 40, we don't know. Okay, now, sir, what is VYB? What is VYB meaning? VYB is nothing but VYN minus VBN. VYN minus VBN, nothing but VYB is the vector combination of VYN and reverse vector of VBN. Minus VBN means reverse vector of VBN. If you are adding these two vectorially, we are going to get VYB. Okay. For this purpose, what we require? VYN we require. Sir, it is there, VYN is there. What else we require? Minus VBN, but we have VBN here. Simply reverse it. So if you are reversing that vector, right? this is minus VBN, right? VYN is there, VBN I have reversed it. Okay. Now, after that what you have to do, simply what you have to do, right? VYN and minus VBN vector combination. Okay. If you are adding these two, VYN and minus VBN, VYN and minus VBN, if you are adding vectorially, what will happen? This one. So what is this vector, guys? VYB. VYB. Okay. What we got, what we require, VYB, it is there. What we require, IR, it is there. So what else we require finally? Angle between VYB and IR we require. VYB and IR. Kindly concentrate. This is VYB and this is IR. So where is IR? Where is VYB? Kindly go through it properly. And this angle we require. Right? VYB and IR. Now tell me, what is this angle? What is this angle? Those on the line try to answer what is this angle. Now, be clear. Sir, kindly follow my hand movement here. From here to here, 120 degrees. What is this? This is 120. And here to here, 180. Yes or no? Straight line. If this is 120, here to here, 180, therefore this will be 60. Therefore, this angle will be 60. This angle from VRN to this one 60. Okay, keep it. And from here to here, 120. Here to here, 180. Therefore, this angle will be 60. Sir, if this is 60, half of this will be 30. Sir, from here to here, 60, this is 30, 90 degrees. So therefore, I am indicating that from this point to this point, it is 90. From where to where? VRN to this VYB, it is 90. But what we require? VYB to IR only. So 90 minus 5. Very, very simple. This angle is 90 minus 5. Clear? After drawing this, just analyze it. But I have given that 120, 180, like that step by step I gave you. Just follow this 90 minus 5. After getting this, let us write the equation over. W is equal to VYB IR cos of angle between VYB and IR. Angle between VYB and IR, just now we have observed 90 minus 5. Substitute 90 minus 5. Okay. Sir, what is VYB? VYB is the line voltage. So simply I am writing VL. What is IR? IR is the line current as well as phase current. So simply IL. Simply IL. And cos 90 minus something. So simply sin. This is the wattmeter reading finally in this connection. Which connection? Current coil is in one phase, potential coil is between other two phases. This is the wattmeter reading. Okay. Now with this, what we can say? Sir, V into I into sine. V into I into sine means reactive power. Yes, this power is reactive power. This power is reactive power. Now, what is the unit of this reactive power? Unit is volt ampere reactive. Volt ampere reactive is nothing but reactive power. Okay, this is the total conceptual explanation to get reactive power with which connection? 1 wattmeter, current coil is in one phase, potential coil is between other two phases. This is a special topic in this entire power measurement. Okay, this is the concept. After this, let's solve one question on this topic. After that, different models of questions which are playing the crucial role in this measurement of power chapter. Let us take. Now let us take the question on this topic first. On this topic, the question will be given like this. If you observe the question, it looks like very lengthy, but have the patience to read the question first. Have the patience to read the question and have the patience to observe the options also. Then answer will be very, very, very simple. Okay, now check it. in this question, a watt meter reads how much value? 400 watts. Okay, try to understand each and every word. Watt meter reads 400 watts, but when its current coil is in R phase, where the current coil? R phase, and its pressure coil or potential coil we say, and its pressure coil is connected between, try to understand, connected between this phase means R phase. Current coil is in R phase, pressure coil is between this phase means R phase, and neutral of a symmetrical three-phase system supplying a balanced star connection, 0.8 power factor lagging load. Nothing but where the watt meter is connected, try to understand that. Current coil is in R phase, potential coil is between this phase and neutral means R phase and neutral, of a so and so star connected balanced, power factor of the load is 0.8. And in this he mentioned phase sequence is RYB. Okay, these are data, but some other data is there. After that he has done something, we'll see that later. But as of now, whatever the data we have seen, I am going to draw the figure for that. I am going to draw the circuit diagram for that. What is that? Right. In this, it is a star connected load, right? So let me take the star connected load first. This is a star connected load, and you clearly mention it is a balanced load. It is clearly mentioned that it is a balanced load. Here Z and Z, power factor is 0.8 lagging inductive load he mentioned, 0.8 lagging load, and then this is neutral, and taking simply RYB some circuit connection. Okay, right. Sir, where the current coil is connected? The current coil is connected in R phase. He has clearly given that current coil is in the R phase, and its pressure coil is between this phase and neutral, between this phase and neutral. So what is this phase? R phase only. Now neutral wire I am drawing with dotted line. This is a neutral wire, and it is being connected between this phase and neutral of a corresponding star connected system. Okay, in this connection, watt meter reads which power? Watt meter is perfectly across one phase. It reads which power? Single phase power. But he has given that this watt meter reads 400 watts. This watt meter reads 400 watts is given. Okay, now tell me, in this diagram or in this connection, watt meter reads which power? Watt meter reads which power? Single phase power. Let us write that. Therefore, W is equal to V phase, I phase, cos phi is equal to 400 watts. He has given in the data where a watt meter reads 400 watts in this connection. Okay, so therefore, from this what we can achieve? Sir, V phase, I phase, what is cos phi? 0.8. That is equal to 400. That is equal to 400. Sir, from this, can we calculate V phase, I phase is equal to 400 by 0.8. So we are going to get 500. Are you clear? Okay. So with the given data up to now whatever we have seen, with the given data, what is the V phase and I phase value we have received means simply 500. Okay, right. Now let us read the other part of the question, continuation part. Up to this we have seen, no. After this he has done some modification. What is that? what will be the reading of this wattmeter? What will be the reading of this wattmeter? Okay. If it's pressure coil alone, try to understand, after having some modification of the circuit, how much is the corresponding power or corresponding reading he is asking. Okay. What will be the reading of this wattmeter? If it's a pressure coil alone, is reconnected between B and Y phases. B and Y. Only potential coil is removed from that, separately removed that, alone connected between B and Y phases, and clearly mention that all other connections remaining as before. All other connections remaining as before. Means he has disturbed only potential coil such that the connection is removed and connected between Y and B phases. Let us do that. Let us do that. Sir, load not disturbed, same star connected load only. Right? No change in this. Here, current coil also not changed. Current coil not changed, only potential coil is changed. This is R, Y and B we have taken. This is neutral point and this is 0.8 lagging load. Everything is same. Only potential coil alone, pressure coil alone reconnected between B and Y. So that's why in this alone potential coil alone is reconnected between, potential coil alone is reconnected between Y and B phases. Okay. Under this connection, wattmeter reads dash. This is what the question he is asking. This is what the question he is asking. What is it? In this, wattmeter reading is dash. This is the diagram. Just now we have taken the concept or not. Reactive power measurement by 1 wattmeter. What you have taken? Current coil is in one phase. Potential coil is between other two phases. So, indirectly what he is asking? Find out the reactive power. Okay. Under this connection, just now we have taken the derivation complete thing. What is the wattmeter reading? Under this connection, wattmeter reads which value? VL, IL, sin phi. Just now we have derived VL, IL, sin phi. But sir, VL, IL, sin phi not given, no sir. But how do we proceed? Means small logic. Sir, power factor is cos phi. Okay. Power factor cos phi is 0.8. I hope everyone knows. Cos phi is 0.8. Sin phi will be 0.6. Cos phi is 0.8. Sin phi will be 0.6. Okay. Sir, sin phi is there. Okay. But VL, IL. VL is not given. IL is not given. But don't worry. Simply, as it is the star connection, VL is equal to root 3 times of V phase. Root 3 times of V phase. IL is equal to I phase. IL is equal to I phase. Sin phi as it is. Sin phi as it is. Okay. Now check it. Sir, root 3. What is V phase, I phase combination? In the earlier data, V phase, I phase, we have calculated, we have obtained 500. So therefore, substitute 500. Substitute 500 into sin phi 0.6. Just calculate this over. But what is the unit? VAR, volt ampere reactive. That's why read the entire question every time. Point to point, you need to observe the things. Okay. Now, if you simplify this, you will be getting 519.46 or something, simply 519 VAR. This is the entire thing you have to do. Generally, this much of lengthy problem, 2 marks question. Of course, while I am explaining, I am taking 10-15 minutes of time to inject the topic. But once you practice it, maximum to maximum, within 2 minutes, you can solve it. Practice in that way. This is the total discussion regarding reactive power measurement concept and reactive power calculation in the corresponding given circuit. Okay. Now, this is a 2 marks model. Sir, from the same topic, how 1 mark question is being asked? How 1 mark question is being asked? Otherwise, in the ESE prelims, how the question is being asked. Very simple. They will give the question like this. They will give the question like this. Here, this is current coil. They will mention clearly. And these are the three lines. These are the three lines. This is R, Y and B. R, Y and B. And to confuse you, they will give the potential coil like this. They will give the potential coil like this. Like this. This is potential coil. Right? This is the connection. What meter reading is proportional to? The question is like, what meter reading? What meter reading is proportional to dash? What meter reading is proportional to dash? Clear? Right. So in this connection, people are getting confused, like current coil, potential coil, confusing. Actually, this potential coil is here only, like this potential coil. One line is here, one line is here. That is what our topic. But to confuse you, current coil and potential coil are given some spacious notation. Don't worry. Simply in this, what is that? Current coil is in R phase. Potential coil is between other two phases. The wattmeter reading is proportional to dash. Wattmeter reading is proportional to dash. The options will be given like this. VI sin phi and VI cos phi, VI tan phi, VI tan phi, something else is given. Simply I am giving, just normally I am giving like this. For example, what is the answer for this? Current coil is in one phase, potential coil is between other two phases, means it is proportional to reactive power. So simply answer is reactive power. In this model, 1 mark question generally possible, or any numerical is given generally in 2 marks model. So this is the total discussion regarding reactive power. It is a special topic, I told you. Okay. After this topic, let us take different sorts of questions, different types of questions from this topic. In the measurement of power, different connections will be there. Any connection is given, no need to worry. Any connection is given, no need to worry. Observe the wattmeter coil connections, then proceed. Very, very, very simple. Okay. Now let us take one more question here. It is also looking like lengthy data, but if you follow the corresponding data, answer will be very simple. A single phase load is connected. First line is very important. In this question, single phase load is connected between R and Y. Actually, single phase load means where we have to connect R and N, otherwise Y and N, otherwise B and N. But in this he has connected R and Y terminals of a 415 volt symmetrical 3-phase, 415 volt symmetrical 3-phase, right? 4-wire system, symmetrical 3-phase 4-wire system. Sir, 3-phase 4-wire means automatically star connection, indirectly star connection is given, and phase sequence is RYB. Generally, it will be mentioned in the question. Suppose if he is not mentioning, don't worry. If he is not mentioning, take it as the RYB sequence. Take it as the RYB sequence. Okay. Now, a wattmeter is connected. A wattmeter is connected in the system as shown in figure. I will show the figure. The power factor of the load is 0.8. Power factor is given as 0.8. Lagging, very, very important, lagging. The wattmeter will read dash. The wattmeter read dash. So what is the circuit diagram? This is the circuit diagram. In this entire diagram, star shape is not given, but he has mentioned 3-phase, 4-wire, automatically star connection. Neutral wire is there, generally star connection. Okay, sir. Single phase load connected between R and Y. Okay, what is the voltage? 415 volt. Now tell me, what is this 415 in this figure he has given? Is it line voltage or phase voltage? Line voltage, because R and Y. If anything is between R and N, Y and N, B and N, that will be the phase, but he has given R and Y. So therefore, this is line voltage, that is 415 volt line voltage. Okay, right. Now, after getting this, sir, wattmeter connection, he is asking wattmeter reading. Okay, we need to observe the wattmeter connections. I told you, any sort of connection is given, don't get afraid of looking at that figure. By seeing that figure, don't get tensed. Simply observe the connections and write the equation first. What is it? Sir, wattmeter reading is equal to, wattmeter reading is equal to, this is a potential coil, this is a current coil because series, and this is in parallel. Where the potential coil is being connected, B and N, so simply VBN, VBN. And where the current coil is connected, here many people are doing the mistake unknowingly. What is that? Sir, current coil is in R. Okay, they are writing R. They are writing R. But if a second letter is not written, that indicates IRN, IRN. But do we have this current coil from R to N here? No. R to Y is there. That's why clearly mentioned RY. Clearly mentioned RY. After that, cos of angle between VBN and IRY. Angle between VBN and IRY. Clear? This is a total thing. VBN, IRY, cos of so and so value. Now very simple. We need to get VBN in the phasor diagram, IRY in the phasor diagram, then angle between these two. Very, very simple. Now let us draw. But before drawing the phasor diagram, one key point, very, very important point is, load is connected between R and Y. He has mentioned clearly in the statement, in the figure also clearly available. Therefore, that too it is lagging load. Therefore, IRY lags the VRY. Be clear? The load is between R and Y. So that's why current from R to Y, that is IRY, lags the VRY, lags the VRY by how many degrees? 0.8 power factor lag means 36.86. Therefore, here phi is equal to 36.86 degrees. Of course, 0.8 cos phi 0.8, phi will be 36.86. Now I am writing that statement here. I am writing that statement, right? Here, I'll write this wattmeter equation again. Here options are there, right? Now, sir, here IRY lags VRY, IRY lags VRY by 36.86. This statement is playing the role, otherwise there are lot of chances to get the wrong answer. That's why IRY lagging by VRY, not by VRN. IRY lagging the VRY, not by VRN. Why? The load notation is not at all with RN. The load is R and Y, means wherever the load is connected, that voltage and that current only should be taken. Okay, right. Now, I am writing, what is it? W equal to VBN IRY cos of angle between VBN and IRY. Earlier only, but I am writing again. Now, sir, let us draw the phasor diagram. This is VRN. This is VRN. This is VYN. This is VBN. VRN, VYN, VBN. VRN, VYN, VBN. Okay. Now, sir, what we require? IRY lags the VRY. What is VRY? VRN minus VYN. VRY nothing but VRN minus VYN. Sir, RN is there, but minus VYN is not there. Simply reverse it. This vector is reversed like this. What is this vector? minus Vyn. Minus Vyn. Okay. After that, sir, Vrn vector minus Vyn vector both must be combined vectorially to get Vry vector. So simply this vector is Vry vector. Vry. Okay, right, sir. We have got Vry, okay, but Iry lags Vry by 36.86. Now tell me, where should be Iry? Sir, this is Vry. What is this angle? This angle is 30. Why? This total will be 60, means it will be 30. But Iry lags the Vry by 36.86, means I am drawing here. This is Iry. This angle is 6.86. Therefore, Iry lags the Vry by 36.86. But many people are drawing this directly with Rn as 36. No, Iry directly with Vry according to the circuit diagram. That's why 36.86 is this. Okay, now finally, which angle we require? Which angle we require? Vbn and Iry. Vbn is this, Iry is this. So this angle we require. This angle we require. What is this angle? Very simple, guys. Vbn to Vrn. Vbn to Vrn is 120. And from here to here, 6.86. So therefore, angle will be 126.86. Therefore, this angle will be 126.86 degrees. 126.86 degrees. Clear? Right. Now, let us proceed. Therefore, watt meter reading is Vbn Iry cos of angle between Vbn and Iry. Clear? Now, sir, what is Vbn? Vbn is a phase voltage or line voltage? Phase voltage, but in the figure already gave that V line, that is 415. In the star connection, line to phase means line by root 3. So therefore, simply 415 by root 3. Okay, into what is Iry? What is Iry? Iry is nothing but here Iry. Kindly follow. Current from R to Y. Current from R to Y. Iry nothing but Vry by this impedance. How much is the value? 100. Current coil impedance can be neglected. So therefore, simply into 415 by 100. 415 by 100 into cos of angle between Vbn and Iry. How much we got? 126.86. 126.86 degrees. In this way, try to write each and every step when you are practicing. Then the procedure will be very simple. Only this calculation, simply cos 126.86, it will be coming in minus notation. If you see the options, yes, minus is there, no need to worry. Actually, if you simplify this, you will be getting minus 596 approximately so many watts. This is the answer. If you see the options, nearby value is given, that is, yes, minus 597. Minus 597 or minus 596.46 something. So simply minus 596 is the answer. So in this way, the entire procedure is available. Clear? Now let us take one more question. Right, here the figure shows a three-phase delta connected. Sir, always why are you taking star connected? Generally, you may be getting the doubt. That's why I'm taking delta connected also. Right? Three-phase delta connected load supplied from a 400 volt, 50 hertz, three-phase balanced source. Three-phase balanced source. The pressure coil and current coil of a wattmeter are connected to the load as shown. I'll show the figure. With the coil pull, I'll come to this entire statement later. The wattmeter reading will be dash. They're asking what is the wattmeter reading. Let us see the diagram first. This is the diagram they have given. And these are the options they have provided. See, this is a three-phase balanced supply. Three-phase balanced supply. Okay. This is one load, second load, and here potential coil. He has mentioned clearly current coil and potential coils are connected in the circuit as shown. Yes, this is circuit shown. Okay. Now, here, sir, this is A. I am taking this as A because same point. This is B. Yes, I am taking this as B. Yes, this point is C. I am taking, yes, this point also C. Okay. Now, which source it is? Balanced one. He mentioned clearly it is a balanced source. It is a balanced source. Okay. So, therefore, if balanced source is there, what is the phase displacement? 120, 120. But in this question, has he given any sequence? No. So, therefore, let us assume one sequence that is, A, B, C is the sequence. You can take A, C, B also, no problem. One of the sequences I am taking. Sir, if it is A, B, C sequence, what is the supply voltage VAB? What is the supply voltage VAB? What is the supply voltage VBC? What is the supply voltage VCA? Okay, check it. Sir, balanced supply 400 is given at the terminal box. So, what does it mean? Terminal to terminal 400, terminal to terminal again 400, here this terminal to one more terminal 400. So, therefore, simply yes 400, here also 400 because it is a balanced source. Now, tell me, as it is a balanced source, I am taking AB, no? So, AB, BC, CA like that will be there, no? ABC sequence for clarity purpose. I am writing elaboratedly ABC is the sequence. Okay, but how do we get the order? AB, BC and then CA. AB, BC and then CA. That's what the point, right? Okay. Now, AB, BC, CA is there. 400, 400 and 400. Okay. Now, the point is, I am taking AB as the first one 0 degrees. AB as the first one 0 degrees. After AB, which degrees later it will be there? 120. So, therefore, that later 120 I am taking as minus means lagging. AB is here. After this means lagging. So, minus 120. After this again, one more. After this again, one more. So, therefore, minus 240. Clear? Right. These are the supply values. Okay. Okay. Now, observe this entire thing. All what I told you, if any wattmeter structure, wattmeter connection is given, wattmeter structure, wattmeter connection is given, what you have to do? Potential coil voltage, current coil current, we have to give potential coil voltage and current coil current. Now, let us write the wattmeter equation first. Wattmeter equation is voltage across potential coil, current through current coil into cos of voltage across potential coil and current through current coil. Very simple everyone, every time. Now tell me, potential coil is between B and C. So what is the order A, B, C? No. So I am writing, yes, this is VBC terminal. Okay. This is potential coil, this is BC terminal name, and then current coil is between C and A. Current coil is between C and A. Current coil impedance is neglected. So therefore, current is ICA. Current is ICA and cos of angle between VBC and ICA. VBC and ICA. Okay. Now, what is VBC? What is ICA? Angle between these two will be the answer. Very simple. Now, tell me. From the diagram only or from the equation, already we got it. VBC directly there. Okay, half of the problem is done. So let me write that. VBC is how much? 400 at an angle minus 120. Okay, happy VBC is there, no worries. Now sir, how do you get ICA, current through this C and A? How do you get ICA? How do you get ICA? Can you try to observe? Current through this, what is that? Voltage across CA by impedance. What is the impedance? 100. Current coil impedance is neglected. So therefore, ICA is equal to VCA by Z. So therefore, simply ICA is equal to VCA by Z. ICA is equal to VCA by Z. What is VCA? Check it here. 400 at an angle minus 240. 400 at an angle minus 240 divided by, what is Z given in the circuit? Z is given as 100. So therefore, this Z is 100. Okay. Now, 400 by 100, 4 at an angle minus 240. At an angle minus 240, this is ICA. Okay. Sir, VBC we require, it is there. ICA we require, it is also obtained. Now let us write both together. Therefore, VBC is equal to 400 at an angle minus 120 degrees and ICA is equal to 4 at an angle minus 240. We got it. What we require? Yes, VBC, ICA, got it, magnitude, and angle also there. Yes, we can get it. Okay. Now, therefore, now let us write the wattmeter reading. So what is that wattmeter reading? Wattmeter reading is equal to VBC ICA into cos of angle between VBC and ICA. Now, sir, what is VBC magnitude? 400. Only magnitude into what is ICA magnitude? 4. But sometimes few students are generally, right? They are stopping here. They are forgetting this entire thing. They are forgetting this angle. If they are forgetting, what happens? Last but one step, very, very important. While you are choosing the option, it plays the crucial role. 400 into 4, in hurry, 1600 they are writing. That's why, even after doing this much of hard work, last step, if you are writing the last step, don't do the mistake. What is it? Let us see. 400 into 4, suppose if you write 1600, see the options once. 1600 there. That's why whatever the small mistake we do generally, with that mistake some answer will be there, that will be available in the options in many of the cases. So that's why don't be in a hurry. So what is it? 400 into 4 into cos of, right. Here one more mistake generally done by many people. Angle between VBC and ICA. Sir, VBC, ICA, one is at minus 120, one is at minus 240. What is the angle difference between those two? Many people are writing, sir, 360 or 240, something they are saying. So for that purpose, last step, kindly focus. This is the reference vector, for example. This is a reference vector. VBC is at minus 120. So this is VBC, right? Minus 120 means lagging. Okay. After that, ICA is at minus 240, lagging by 240. This will be ICA. This angle is 240. Okay. What we require? We require angle between VBC and ICA. Check it. VBC and ICA. VBC and ICA. This is what we require. Now tell me, is it 120 or not? Obviously, this is 120. So therefore, substitute here cos 120. Cos 120. Okay. If you simplify this, sir, you are going to get minus 800. Minus 800 watts. This is the answer generally. Now go to the options. 0 is there, 800 is there, 1600 is there, 400 is there, minus 800 is not there. So with this, many of the cases, generally people are taking like, okay, minus 800, below 0, reading is not available, therefore it shows 0. In that way they are taking. No guys, kindly read the question now. This point is very, very, very important. Kindly focus. Last step. Here, with the coil polarities, suitably selected to ensure a positive deflection, means the coil polarities are adjusted such that it is showing positive deflection. It is showing positive deflection. So what does it mean? Even though after taking this entire thing, even though you are getting minus 800, according to the given data, the coil polarities are suitably selected to ensure, means negative is there, they are reversing the coil, etc. They are trying to get 800 plus. So therefore, according to the given data, plus 800 watts is the answer. Sir, minus 800 blindly made into plus. No, it is not blindly made into plus 800. It is given that coil polarities are suitably selected to ensure a positive deflection. So therefore, minus is there. But after this observation, okay, coil polarities are suitably adjusted accordingly. So based on that, it will be showing the plus 800 only. Yes, answer is plus 800. And go to the options. 800 is the answer. 800 is the answer. Clear guys? So this is a total discussion for today's session. But before leaving, kindly concentrate. Day before yesterday, we have done one session on preparation strategy. What is the weightage and what are the important topics or step-by-step topics we have taken, and how to prepare, do's and don'ts I have taken. Importance of measurement subject I have shown, go through that video also. And in this session, right, from the measurement subject, measurement of power, that is one of the important topics. From that, concept of reactive power and few other varieties of questions of power related thing we have taken. So with this, kindly prepare well, don't waste the time. All the best. Thank you.